Everyone's always talking about AI, but most people still have no clue where it actually came from. You might not know these scientists, but they've changed your life more than Taylor Swift, the iPhone, and TikTok put together. You've seen the news headlines, the startup demos, the $100 million job offers that have graced your social media feeds. But you've never seen the full history of AI. And without that context, it becomes almost impossible to distinguish between what's noise, what's hype, which is 90% of what you see online, and what's actually real and worth spending your time learning. In this video, I'm going to go over what I think is the best summary of the entire history of artificial intelligence, from ancient Greece to the Industrial Revolution, to chess-playing AIs, to the expansion of machine learning, deep learning, Gen AI, and LLMs and agents, to where we are today. That way, as a software engineer or a business professional, you have a better idea of what tools are actually going to stick and are worth learning as future investments of your career. The history of AI begins almost 4,000 years ago in ancient Greece, specifically in Greek mythology. Apparently, the first AI agent is actually this bronze guy named Talos the Automaton. And the story goes that the reason he was created was because the gods Zeus and Hephaestus created this guy to be able to fend off against pirates in the island of Crete, one of the islands of Greece. And so he was an automaton that guarded the island and made 3 laps every single day, which I guess was the first cron job that ever existed. And what he would do is, if he would spot a pirate or an invader, he would throw a boulder at the ships and sink them. Here's also another representation that I think of Talos as well. This is from the game Skyrim, if any of you have ever played it. These are the dwarven little mechatrons, little machines. And the idea is that AI nowadays is more digital, but thinking of AI as very much like a robot or as an automation, I think really helps personify it and helps me be able to explain it to especially non-technical people, like what the AI is actually doing. So the robots people have thought of robots in ancient Greece and in mythology, but nowadays most of the robots exist on our phones. We also have physical robots as well. It's a separate category. So that's how I like to think of agents and AI automatons as well. Then, 3,500 years of mathematics, philosophy, and logic helped bring us to the point where we were able to formalize a lot of this kind of knowledge and philosophy we have into mathematics. This helped Isaac Newton and Leibniz co-invent calculus, specifically differential and integral calculus, which is used in the backpropagation algorithm nowadays for neural networks. And this really helped us formalize a lot of logic, as well as would later help us define what a computer is. Not calculus specifically, but just more the mathematical intuition behind it. What I really like about this example in history, or this time period, is a lot of it was driven by the need to describe physics. So the AI was used as a tool to describe physics. It wasn't that AI itself was invented just for the sake of having AI. It was used for a very specific use case. Then, in the 18th and 19th century, we had the first and second industrial revolutions. This is where a lot of the thought of automation becomes mainstream and everyone knows about it. This is where a lot of that applied mathematics from before was used for machines that helped us in our everyday lives. You have the steam engine that helped us power boats, so that we didn't have to manually row boats like we're a bunch of Vikings anymore. You also used it to help create the combustion engine, which was used in steamboats as well as the car. So that way we didn't have to rely on horses and cattle to pull us around everywhere. We can just use this to automate out horses. That said, horses are still used today in some contexts. Then we have electricity that ultimately helped us rely less on natural gas and to be able to use it more and more uniformly across our towns and cities. We have the typewriter, which technically automated handwriting. You can think of it that way. That said, some handwriting is still used today. But all these inventions brought us in our minds that we should really be using technology. And it brought automation to the forefront of our psyche. Then, in the 20th century, this is when AI really hit puberty. You have World War I and World War II, which, again, through military applications driving scientific advancement, it helped create a lot of inventions in the field of computing, specifically the punch cards and the first general-purpose programmable computer, the ENIAC, which is used originally for military or for mapping out artillery shots for the military. You also have the Enigma, which was solved by Alan Turing, which helped the British and the Allies win World War II. This is a really good movie that I like as well. And so with these programmable computers, what they allowed us to do was essentially bring computing into the mainstream. And as computer science and computers were brought into the mainstream, the idea that you can use this like calculator thing to actually use it for real world use, people thought, why don't we use it to mimic some kind of intelligence? This is where AI came from, and actually the imitation game is actually named after the Turing Test, also made by Alan Turing. The idea of the Turing Test is that it's essentially a way for us to define intelligence by whether or not we can distinguish machine-generated text and human-generated text. ChatGPT nowadays, I would say in maybe like 50% of cases, if you prompt it right, is able to pass the Turing Test. Does this mean that ChatGPT is intelligent? Sure. Does it mean that it's AGI or that it's like a very general intelligent machine? I'm not sure. I would question that. So the Turing Test was more of a start towards our interest in AI. But we also have the artificial neural network that came out, which was invented by Warren McCullin and Walter Pitts. The idea is that they thought that, well, intelligence comes from our brain, so why don't we just model the brain in a computer? And so this was actually taken by a few other guys, primarily Frank Rosenblatt, who actually created the Perceptron out of this, which was one of the first machine learning models out there. The idea is that you're using a similar structure to a neural network, except you're taking in some inputs, you multiply them by some weights, and you get out some prediction, which is applied by a function. This is what we call a single layer neural network, and this gets really into the heart of machine learning. The idea behind machine learning is you have these weights, W1, W0, and all of these. The idea is that you can think of these weights as little knobs that you're turning between like 0 or 1, between -5 and -10. Like they're settings that you tweak in order for the model to make fewer mistakes and to have higher accuracies as it makes predictions. And this is machine learning. This is the learning that comes out of this. And this was a really important contribution in the field of research. Then we had the Dartmouth Conference, where this guy named John McCarthy and Claude Shannon, who, if you've heard of or used Anthropic's Claude model, who is named after, they basically came together and tried to formalize a lot of AI together, and especially in research. And what they did was they led to a lot of advancements, kind of like the Perceptron, as well as other advancements as well. Then for 1950 to 1960, there was kind of like a spike in AI research and development, specifically with symbolic computation and symbolic reasoning, where they were trying to map equations and to model things with equations, kind of like how Isaac Newton modeled physics with equations. Except the issue was, after a few years of doing it, people stopped seeing a lot of results from AI, and thus an AI winter came about. There was a decrease in a lot of funding in research and industry from 1960 to 1980. In these 20 years, it wasn't really fun to be an AI researcher. No one really was doing it, except for this one guy named Yann LeCun, who currently is the head of AI at Meta, and also won the Turing Award. In 1989, he invented the CNN, the Convolutional Neural Network. It's actually not really part of the winter. That's sort of after the winter, but his work really helped us, especially in the field of computer vision and vision processing, especially with a lot of unstructured data. So before, with these perceptrons and neural networks, like, you could work with data in Excel tables very well, but when you give these these perceptrons like an image where the pixels aren't really like well defined, they're not very consistent, then the models break. Whereas the CNN, the difference is instead of flattening all your pixels and treating each pixel individually, you treat groups and regions of the picture as single units, as convolutions, and then you slide this filter across the image and then the model learns the filter. So instead of learning pixels, we learn regions. And this was the huge advancement for convolutional neural networks, specifically for handwritten digit recognition. And this was through the creation of LeNet in 1989. And yeah, 1980 and 1990 was sort of another AI boom with expert systems instead of symbolic reasoning. The idea behind an expert system is that it's some kind of question answering machine or device. You can think of it a lot like ChatGPT back in the 1980s. And during this time, we also had these machine learning models which I'm not going to get into, but they were also very important. And each of these has a Python implementation nowadays that you can use in scikit-learn or some other Python library that I thought were very important. If you are a data scientist, especially if you're working with kind of smaller data sets or more specific data sets, you're probably going to be using these models over an LLM. If you're a software engineer building agents, you're probably going to use LLMs. But these are really important mentions that I think are worth mentioning. So 1980, 1990, Yann LeCun invented the CNN. There was also some work in reinforcement learning by Richard Sutton, which I will talk about in a different video. Then in the 1990s, there was kind of another AI winter. Not as much researcher work was going on for that decade. Until this famous chess player named Garry Kasparov played against IBM's Watson machine, or IBM's Deep Blue machine. Watson is a different thing. Watson's actually that machine that played Jeopardy. That's a totally different AI, which is also something that you should look into. So the Deep Blue machine here, the idea is that it's a chess playing AI that used a combination of tree searching and different ways to find the correct move of an AI, the correct move in chess. And it was actually able to beat this chess grandmaster, and everyone's like, wow. So this brought a lot of excitement into the field of AI. And then from basically 2000, there was the dot-com crash, so maybe slightly less funding, maybe like a slightly third AI winter. But then from 2002, 2005 to 2010, that's when the internet started to really, really boom and became mainstream by everyone, not just like tech people. You had, Facebook came out, and through social media apps, especially like YouTube, Facebook, even, OkCupid, you had a lot more data coming out. And so with a lot more data, you had a lot more things to train your models on. So in 2012, there was this competition called the ImageNet Competition. This competition was essentially classifying between, 300 different classes of images. So instead of just doing cat versus dog, it's doing a whole bunch of things that the image or that the model is trying to classify, which is extremely hard to do. But the winner of that competition was AlexNet. And this model used the CNN's architecture that Yann LeCun invented. And through doing that, these three names became very popular: Alex Krizhevsky, Ilya Sutskever, and Geoffrey Hinton. And if you've been up to date with OpenAI news, you know that Ilya Sutskever was the head of research at OpenAI until he left about a year ago to start his own startup. Geoffrey Hinton is also a huge figure in the field of deep learning, who I'm not going to talk about as much in this video, but he's someone worth mentioning. He invented a lot of different things and was super, super helpful. But yeah, the idea was this ImageNet competition essentially brought out deep convolutional neural networks into the mainstream, where you had these three famous scientists, Ilya Sutskever, Geoffrey Hinton, Alex Krizhevsky, who became celebrities. They became the Ben Stiller, Liam Neeson, and Seth Rogen of the AI world. Then, after the ImageNet competition, in 2014, we had the Generative Adversarial Network invented. It was created by Ian Goodfellow, who now works at DeepMind. And the idea was, this was a lot of the first evolution in the AI world in terms of deepfakes and generating realistic looking data, specifically images here. But It was later then applied to use to generate all kinds of different data like time series, audio, and is now even the basis for development of deepfakes, especially with videos, which now Sora 2 came out like just last week. You saw all those clips, as well as Google's VO3 last summer. A lot of that technology started with generative adversarial nets. The idea is that you have two AI models, the generator and the discriminator. They both work together, whereas the generator generates fake examples of the data, which tries to make it as realistic as possible, whereas the discriminator tries to determine whether or not the fake example is real or fake. And if the generator is able to create such realistic looking data that's able to fool the discriminator, then that's how you know you've had your model trained. And again, this started the basis of a lot of image generation and video generation AI. And the 2010s especially were very big on image classification and working with images just because they're probably the most popular form of unstructured data there is out there. An image can have the subject of the image be any part. There's not always a consistent form of an image. They can be in all sorts of different forms. So the idea that you can take unstructured data, which before you could only work with tabular data with AI, and now you can use unstructured data with AI, that created such a huge revolution that later on in 2016, you had the word deep learning become more and more popularized in mainstream media. Specifically from this paper in Nature by Yann LeCun, Joshua Bengio, and Geoffrey Hinton. Joshua Bengio is also a really big figure in the deep learning AI space. He also published a ton of research, which I think you should read on. And you remember Geoffrey Hinton. This paper got over 100,000 citations to this day and remains one of the most highly cited papers of all time, especially in the AI world. Then as deep learning became more popular, you had more data to work with. Again, more data from social media accounts, more data from enterprises as they started to unify databases, and databases became more popular, more users using the apps, as well as more powerful compute. So GPUs got better from NVIDIA and AMD. And in 2016, that's when a lot of GPUs started to become used for AI. And specifically because of their parallel processing architecture, you could train models at like enormous magnitudes more faster than with just a CPU or previous hardware. Then in 2017, a year later, this was the creation of the transformer. Those of you who know what the transformer is, it's the machine, it's the architecture, the AI that powers LLMs. Attention is All You Need was originally published, it was updated in 2023, but it was originally published in 2017 by Google researchers. And the idea was this is a new type of neural network, or rather it uses multiple neural networks, where it kind of takes in data as formed of tokens, where tokens are kind of sections of the data. Specifically in sentences, tokens are pieces of the data. And then it tries to find context of the data and see how the context changes depending on different parts. And I have a video explaining the transformer model. I'm not going to explain it now. But the idea is this transformer model was very scalable. It was very parallelizable with GPUs, especially with increased data and increased power. And it just became so much more powerful. And these, again, led to the creation of the large language model a little bit later. You can see here, this is an example of tokenization that was used. So you take your data, and because this data is sequential, you want to read it from left to right. Whereas before, what you could do is you could just take each character, feed into a neural network, but not each character is as important as other characters. Some characters or some parts of the word are more important than other words, which these multi-head attention and masked multi-head attention like layers actually capture. So you take the sentence, you split it up into tokens, and you can encode it and you decode it. So the encoder on this left part actually encodes the data, decoder decodes it. You can learn about the transformer in some other videos of mine. And then it led to all these sorts of things. These are actually these are aspects of a transformer that I think are important, that start to become important, especially as you scale large language models, is like these settings you're using, where you're training the model. How does the model behave when you give it billions, trillions, quadrillions of gigabytes of data? The data itself, how good is it? Does it align with what we want our model to output as well? Then you have all these techniques, and then reinforcement learning comes up as well. Then in 2020, you have GPT-3. This was a pretty huge breakthrough. Even before ChatGPT came out, this model was pretty much good enough to start generating sentences. And I actually made a video using this model on my channel to generate emails and put those emails into Gmail. It became my GitHub project with the most amount of stars. The idea is here that it's just generating sentences based on, this is just auto-completion using the Da Vinci models, if any of you remember those. This is the point where transformers became so powerful that they became what we call foundational models. Foundational models, in the word foundation, they capture general knowledge. They're a neural network that can do most things pretty well, can generate and predict most text with a high level of accuracy that you can then use to fine-tune to a specific task you're using. And this is how people generally treated transformers back in the day. And again, you can take the transformer architecture and you can just scale it in parallel. Then transformers became so powerful that 2 years later, OpenAI decided to put transformers into a UI so that anyone could access transformers even outside of the tech world. And this UI became ChatGPT. ChatGPT was, I think, one of the biggest breakthroughs in just making AI become mainstream that would then later lead to these other LLMs. And the idea is that it also, in addition to text, they also created DALL-E 2. So that was an example of a text-to-image model, which was, based off of the generative adversarial network from a few years ago. And they, again, put it into ChatGPT and made it mainstream. And that's kind of the timing of ChatGPT was just perfect, and that's part of the reason why it was so successful, as well as just infrastructure in terms of more GPUs, NVIDIA selling and making more GPUs, models becoming better, and as well as different data sources and APIs allowed AI to become more and more popular and more famous. And when ChatGPT came out in November of 2022, then 2023, AI exploded again. So after ChatGPT came out, all the other tech companies and a bunch of new AI labs popped out and said, hey, we want to create our own LLMs to try to compete in this space. So Meta came up with Llama, you had Mistral, which is a new startup, Claude was made by Anthropic, which is a new startup founded by OpenAI researchers. Google also wanted to get a piece of the pie and created Gemini. Grok was made by xAI and Elon Musk to also get a part of the AI race. Then, as people started to use AI more and more, they kind of understood or started treating the API calls to these LLMs as their own containers or their own little sub-modules. And what we could do is we could call the LLM multiple times to have it be able to solve more complex tasks. And by doing that, we create agents. So Microsoft in 2023 created the AutoGen, which is one of the first agentic frameworks. This is where Agent AI comes in, or Agentic AI comes in, where you can have LLMs prompt each other. And that's where you start to get multi-agent orchestration and a bunch of other things as well. Then in 2024, AutoGen took off and inspired a lot of other libraries and frameworks like Crew AI to be created, as well as other parts of the AI world where LLMs started to get more and more integrated into apps, and people created these different solutions and tools to help them better become more useful in the backends. For example, Retrieval augmented generation with vector databases or just any database helped LLMs be able to get or access to your data, especially in vectorized format, and compare it to your query and give you back the most useful data. You also had the Model Context Protocol, which I have another video explaining how this works. This was created in November of 2024. And the idea here is that, Anthropic wanted to standardize the way we connect agents to tools, where you have a client or MCP client connecting to an MCP server. An MCP server is a bunch of tools like searching the web, accessing your calendar, sending you emails, and then the LLM decides which of those tools to call that the client then calls, and then you have MCP client, MCP server. So it's kind of these advancements in a lot of the software engineering and back-end engineering of AI that happened in 2024. Then in 2025, you have, which I think is the year of Agentic AI. This year is not completed yet, but at the beginning of this year, we had DeepSeek and a bunch of other LLMs which were open source. I think Alibaba also had an LLM, Quen, that came out as well that started to add a lot more competition to the space, and a lot of new models came out. I think Grok 3 and 4 came out, Llama 3 came out, a bunch of new models came out, and this LLM and foundational model space started to become more and more competitive. As well as at the same time, Agentic AI was becoming more popular, where you treat LLMs as their own agents within the back end of your app that can communicate with each other. They can also communicate with your data, with your resources, to essentially make LLMs more useful. And as LLMs become further and further integrated into apps, we're going to start building more and more frameworks and tools for actually utilizing them. So LangChain was a really popular AI agent framework, probably the most popular AI agent framework that was created a few years ago, that is really, really useful for agents and is one example of the many different agentic libraries out there. And as we go into 2026 and into the future, we have a lot of things that could happen that I honestly don't know, but based off of today, I'm going to just give my best predictions on. We know that AI is going to be used in more robotics. That's pretty much guaranteed. The Waymos started being used in San Francisco and Austin 2022 or a few years ago, and currently you can take a Waymo if you're in those cities, as well as some other cities as well in the US. So self-driving cars are starting to become more and more popular, as well as AI getting smarter. I don't know if LLMs are going to power these self-driving cars anytime soon. I guess parts in certain situations they are, but I guess like maybe smaller LLMs are. But we're going to see the further integration of AI into robotics. And this was at one of the Tesla's events this past year. I actually don't remember if this robot was pre-programmed, but we're going to start to see more humanoid robots actually hit the mainstream and being used for more things. This was a movie that came out a few years ago that I think is pretty underrated. It's called Chappie. This was a robot that was used in the police force that went rogue and started thinking for itself. Let's hope that doesn't happen, but we'll start to see and become more and more comfortable with robots being more integrated into our daily lives. And as AI becomes smarter, there's the questions of artificial general and artificial superintelligence. So general intelligence is just AI that can surpass or can do anything that a human does but better. Superintelligence is like this AI that's like smarter than God. It is so smart that we can't even begin to comprehend how smart it is. And while I don't think LLMs are even close, I don't think LLMs are the way we're going to get there, but the philosophy behind a lot of these AI terms and the future of AI is something that we're going to think about more and more often as this field is now going through another boom. And in the future, as robotics become more and more powerful, agents will being used from. And in the future, as agents start to power all of our software and our hardware, we're going to go into a world that's run by agents for us. And we might run into kind of a situation like WALL-E, where as humans, we might not have to do much, but I think we're born to work, we're born to do something. So maybe if anything bad happens to us, the agents can help with us and interact with us in the world. And if the planet isn't destroyed by then, we can actually use agents to power robots and have the robots be governed and have their own laws and all these kinds of things happen. But either way, I think the future is very, very cool to think about, and we get to see it one day at a time. No one knows what's going to happen for sure, but I think we do know that AI is going to be a huge, huge part of the future. And whatever happens to us, I think it's important to be aware of how this technology is used and to use it in your own lives to your benefit. And I hope that was the biggest point of watching this very long video. If you made it till the end, congratulations. You know more than 99% of people about the history of AI. Hopefully you can use this information to benefit yourself and to now understand all these AI terms that are out there. Thanks for watching.